All right, in this worksheet, we talk about this thing called expected value. This is going to be the last section of the probability module. We'll learn how to figure out whether a particular gambling is a good game to play or not. So we learned about probability. So it has to do with something with probability, but we're going to incorporate how much money you're going to win to decide if a game is a good game to play or not. So let's look at number one. Suppose that you're playing a game by rolling a die. Okay, so there's a possibility of 1 through 6. If 6 shows up, you'll win $40. However, if your other number shows up, any other number shows up, you lose 5. You want to figure out if it's mathematically a good game to play or not. So part A, what is the probability of winning? Again, this is kind of like old question. There's one outcome that gives you winning out of 6 possible outcomes. So it'll be 1 out of 6. And what's the probability of losing? It says any other numbers, so 1 through 5 is losing numbers. There are 5 out of 6, so 5 over 6. Just by looking at the probability, is it a good game or not? So here, just by looking at the probability, I want to say it's not, because I have more chance of losing and then we have less chance of winning. It says I only have 1 out of 6 chance of winning, and you have 5 out of 6 chances. So you're going to lose more than you win. Okay. What other factors do you think you need to consider to actually determine if it's a good game or not? So I'm going to go back here and say, well, but you have less chance of winning, but when you win $40. That's a lot of money. And when you lose, you only lose $5, right? So I have a feeling that we need to take that as a consideration as well. So let's see, part D, what other factors do you think you need to consider? The winning amount, 40 versus losing amount, which is only 5. Okay. Right, let's look at the last one. Fill in the given table below of winning amounts and corresponding probabilities. So here, winning amount, I can win 40. So I'm just going to organize the information in a table. Winning, losing amount, I'm going to put 40. Probability, I got 1 over 6. And winning, losing amount is, I'm going to put -5. Here I'm going to highlight negative, because here this is losing. That's why I'm going to put negative numbers. Losing, so negative. Okay, and the probability of that is 5 over 6. So this table kind of encapsulate what information was given in this gambling situation. All right, let's look at expected value. First, what it represents. The expected value of gambling or game represents the average amount of winning or losing if the game was repeated many times. So what we're going to consider is not just one game, but we're going to look at the average winning amount. So basically you'll win sometimes, you lose sometimes, and so it's not fair to just look at one game to determine if the game is good or bad. Basically what we're going to do is we look at, if I were to play this like many times, what's the average amount that I'm going to win or lose. That'll give you more accurate description if the game is good game or bad game to play. If the expected value is positive, then player wins money on average. However, if the expected value is negative, then player loses money on average, because negative value is representing losing. So if the expected value is negative, that means on average you're losing money. When the expected value is exactly equal to 0, the game is called a fair game. That means you're not winning or losing on average. So on average, not winning nor losing. That's what fair game means. Side note, even if the expected value is positive, it doesn't guarantee the player will win each game. Sometimes it's kind of misleading because the expected is positive, so you think, oh, I'm going to have to win all the time, but that's not the case. you're winning on average, that means sometimes you win, sometimes you should lose, but overall you're winning. It doesn't necessarily mean you're winning every single game. So there's no guarantee. The positive expected value means that in a long run, the average winning amount will be positive. Okay? So basically what we're gonna do is, in order to see if the game is a good game to play or not, basically we have to calculate the expected value and see if the number comes out positive or negative. Alright, so how do we actually calculate the expected value? To calculate the expected value, first we're going to make a table with all possible winning and losing outcomes with its corresponding probability, just like the table we made here in previous questions. Like there's a winning amount, losing amount, there's a probability, corresponding probability. So I'll write all these amounts out and then multiply each outcome by corresponding probability. Add up all the products, then when you add up all the products, the answer will be the expected value, right? So let's look at some more example. Actually, we're going back to the first example we did. So let me just copy the answer, 50, -5. So here, I'm just going to copy the answers. So we had 40, -5, 1/6, 5/6. So basically we just did our first step of making a table with all the outcomes. So second step, it says multiply each outcome by its corresponding probability. Okay, so what I'm going to do is I'm going to look at there's winning amount, I'm going to multiply that by its corresponding probability. So okay, I'm going to do the other side calculation here. 40 times 1/6 and then -5 times 5/6. And what's next? It says add up all the products. When you add up all the products, the answer will give you expected value. So I have the first product, I have the second product. So basically what they're saying, to add up these two numbers. Okay. So basically I'm going to type in 40 times 1/6 plus -5 times 5/6. If you calculate this out, you're going to get 2.5. Okay, so my answer is $2.5. Again, the amount unit here is you're using dollars, so $2.50. Oh, okay. We notice it's positive. Sometimes your answer is going to be like -1, -5, whatever, right? Depends on the situation. Here, I have to get positive 2.5, so that's my expected value. Interpretation of this number is if I were to play this. So if I were to play this game many times, I'll win $2.50 on average. I'm gonna highlight average, right? So I want to say this is a good game to play. This is a good game because you have a positive expected value. Again, there's no guarantee you're going to win all the time. Basically, if I have to kind of look at it in terms of example, it might be the case like win, I lose, then I might win again. So this is if I were to repeat this game like a bunch of times. So maybe I get lucky, maybe I get unlucky a bunch of times. So it's going to be like this, just a bunch of 40s and a lot more -5s. If I were to average all this, it'll come out to be $2.50. All right, let's look at the next question. I'm gonna get started on next question. Have you guys kind of finished it? Number 4 says, suppose that you purchase a raffle ticket to help out a charity. The raffle ticket costs $5, and then ticket is they're selling 2,000 tickets. One of them will be drawn, and the person holding the ticket will give the prize of $4,000. Wow, okay, that's a lot of money. So basically, if I buy this ticket, I could win $4,000. But if I don't win anything, basically I just lost $5, right? So winning and losing amount. Losing amount is easy. It's $5. Here for the winning amount, I just have to be super careful, because even though I win $4,000, because I already paid $5, the amount I actually win is $3,995, because I spent $5 to win 4,000. So the amount I actually won is now that 3,995. So 4,000 minus 5. So there's a situation where you already pay for something and then you win something else. Then I have to kind of look at the difference. So I'm going to subtract to get the winning amount. So I'm going to pause here. I'm going to have you guys finish the rest of number 4 to figure out if it's a good raffle ticket to buy or not, just mathematically speaking. And then let's meet back at number 5. All right, if you're done with number 4, let's go on to number 5 here. Again, number 5, a friend is offering to play a game in which you roll a single die, just like our first example. If an even number shows up, you win the dollar amount of 5 times whatever you rolled. So for example, if you roll 4, it's 5 times 4, which is 20. If you rolled 2, then 2 times 5 is 10, that's like the winning amount, and so on and so forth. If an odd number shows up, then you pay 25. Oh, so you're gonna lose 25. Okay, make a table with possible winning and losing outcomes. Okay, we'll do the losing one first. That's the easiest part, negative 25. So that means you're rolling odd numbers, basically 1, 3, 5 gives you negative 25. Good. If I roll 2, it says it's times whatever you roll, so 2 times 5 is 10. That's the winning amount. If you rolled 4, it says it's 20. If you have rolled 6, that means 6 times 5 is 30. That's how much you're gonna win. So here in the middle, dollar sign. So this one not only have 2 outcomes, but there are a bunch of different ways you can win, right? So it's possible that it's just not one winning and one losing. It could be just different amount for winnings or different amount for losing, depends on what the situation is. Probability winning $10, 1 over 6, 1 over 6, 1 over 6, and this is 3 over 6. The last one is 3 over 6 because 1, 3, 5 is a losing number, so 3 out of 6. Okay, I'm gonna pause and then I'll have you finish the rest of number 5 and number 6, and that's it for this worksheet.